So we're now ready to cover a final case study that'll demonstrate how parallel streams works. And this is going to be the search with parallel stream spliterator approach. And it's a very interesting case study that will show how you can take parallelism to the nth degree by parallelizing the searching for phrases within a given piece of work of Shakespeare, like one of the plays or the collection of sonnets. And it's going to show off the use of how to write parallel spliterators, which is pretty cool. This solution fixes a con with the sequential versions we've looked at before, and even the parallel versions that we looked at before, where it didn't totally maximize the use of parallel processing. So this is going to try to take it to the next level. And you can see that this version, the parallel spliterator version, is indeed a little bit faster than the more conventional parallel streams version. So if you take a look at the Search Stream Gang case study, there's a whole slew of different ways of doing parallel processing. We've talked about a handful of those. We looked at the sequential version. We took a look at the parallel streams version, which was very simple modification to the sequential version. And this approach is yet another way to do things. So the search with parallel spliterator implementation uses parallel streams in three ways. It uses it to search chunks of input in parallel. And the input here, the input chunks would be a work of Shakespeare, like Hamlet or Macbeth. It also searches chunks of phrases in parallel, and that would be a particular phrase like, "To thine own self be true," or "Neither a borrower nor a lender be." And it also searches chunks of each input string in parallel. And this is the piece that we haven't talked about before. So if you have a particular work of Shakespeare, and you've got phrases that could appear multiple places, like the word anon, which is a common Shakespeare word, then this will look for anon in parallel in that particular work. So this is by far the most aggressive parallelism strategy we've seen, because it basically has three heads, like Cerberus, or Cerberus, who's the guardian of the gates to Hades in Greek mythology. When you run this program, and of course your mileage always will vary depending on the type of computer you have, how many cores, how much memory, and so on, which version of the virtual machine you're using, you can see that the relative contribution is shown here for each of the different parallel dimensions. Remember the three parallel dimensions. And this particular program is kind of fun because it actually will do them different ways, all the different combinatorial ways, ranging from everything being sequential spliterator, sequential phrases, sequential input, to parallel spliterator, parallel phrases, parallel input. And you can see that the totally sequential version is substantially slower than the total parallel version, and then these different things impact the performance in different ways. What's also interesting, I ran this a couple different ways. This has all the works of Shakespeare, all 37 plays, and then all the sonnets together as 38 different strings with whatever size each of those works are. And then I did another test where I just took the complete works of Shakespeare and split them in half. So I had two very long strings. And you can see it's slightly faster the longer the strings, which would make sense because you're doing more work in parallel that way. So longer strings provide better opportunity to leverage the benefits of parallelism with respect to the parallel spliterator, which is what we're going to be talking about. So here's the key part of this program where parallel spliterators are used. So this is the process input method. We've talked about this before. And in this particular case, we're going to go ahead and take the input string, which is the work of Shakespeare, get the title from it. Then we get the rest of the string, which is the work itself, all the words and the characters and so on in their dialogue, in various forms of iambic pentameter and other types of poetry. And then we're going to call this search for phrase method. And in this case, we're going to pass in the value of true. And what that means is use a parallel spliterator to search for the phrase in that work of Shakespeare. In the version we did before, which was just the plain old parallel streams version, that value was false. So we did a sequential search. Here's what the search for phrase method looks like. It's kind of cool. It takes the phrase we're looking for, the work we're searching, the title, and whether we want to run in parallel or not. And then it goes ahead and calls this helper method we've seen a number of times called stream_support.stream. This is the one that takes a spliterator and turns it into either a sequential or parallel stream. And you can see we call new phrase match Spliterator, which we'll look at in a second. That's going to make us a Spliterator for the input and the phrase. And then depending on the parameter we pass in, we either do this with sequential streams or with parallel streams. And so here we're going to focus on the parallel version. So let's take a look at the methods in phrase match Spliterator. And that'll be the next part of the lesson.